Hello, and thank you for joining us today for our live webinar, Navigating the Maritime Future, Turning Data into Decisions. My name is Peter Sparks. I am the Chief Executive of the UK Hydrographic Office. During this webinar, we are going to explore the significant role that data can play in helping to address two of the biggest challenges our industry faces: digitalisation and decarbonisation. As part of this, we will look back at some of the key conversations that took place during our panel discussion at London International Shipping Week, where we were joined by a fantastic selection of panellists from across the industry. We really want you to get involved in the conversation, so please do submit your questions throughout the session, and we will answer as many as possible during our live Q&A at the end. What we'd like to know is, where in the world are you tuning in from today? Thank you, everyone, and it's great to see we are joined by viewers from across the globe today. Before we get started, I want to reflect on why the UK Hydrographic Office believes data is essential as we enter this new chapter across shipping and the wider maritime industry. It was no surprise that decarbonisation took centre stage during discussions at London International Shipping Week. Decarbonisation is one of the most pressing issues facing our industry and indeed the world. Today, over 90% of UK trade by volume is carried at sea. Our daily lives mean that all of us, in some way, rely on carbon-intensive bulkers, tankers, and container ships. Perhaps it's not a surprising statistic then that the maritime sector is responsible for 2.8% of the world's greenhouse gas emissions. To put that into context, that's the same as the emissions generated by Germany, all from our industry. And unlike Germany, shipping does not come under the Paris Agreement. If we do nothing, shipping's emissions will increase by a further 10% by 2050, as shown in this graphic from the Maersk McKinney Moller Centre for Zero Carbon Shipping. So while our industry may be vital to the world economy, we certainly have the carbon footprint to show for it. If nothing changes, we will generate an even larger share of global CO2 total at a time when other industries and nations are cutting their carbon output. To combat this, you will have seen the new greenhouse gas strategy set out by the International Maritime Organization, as announced at the end of MEPC earlier this year. Their targets aim to take us to a net zero shipping industry by around the year 2050. In other words, a lot is about to change, and it's going to change very quickly. Thankfully, the other major change that is coming and transforming our industry is digitalisation. Innovation in technology, connectivity, and AI are paving the way for new solutions that will not only help shipping become more efficient, which will in turn save costs, but also help to reduce emissions to help better meet these ambitious but necessary decarbonisation targets. Because it's not all bad news. The potential for improvement is huge. In fact, if we collectively are able to improve efficiencies by just 8%, around 1% per year until 2030, we could save 1 exajoule of energy. That's the equivalent of 24 million tonnes of fuel oil. As global demand for fossil fuel changes within shipping, and indeed the world, this could have a significant impact on the world's trading fleet as we know it. For example, today, in 2023, over 40% of maritime trade by weight consists of hydrocarbons. But as shipping adopts new voyage optimisation solutions and seeks fuel efficiencies, this could alter the very makeup of the global fleet in years to come. Other parts of the industry are already innovating to develop solutions such as new propulsion technologies or cleaner alternative fuels. But we believe data has an important role to play in unlocking the benefits of digitalisation and addressing the need to decarbonise. So why is data important? We now have more data at our fingertips than ever before. This includes information on the depth and nature of the seabed, tidal currents and water levels, real-time data on shipping routes and operations, along with increasingly powerful tools to be able to use that data for decision-making. And the same can be said for us here at the UK Hydrographic Office. For those of you who aren't familiar with the UKHO, we collate, process and analyse terabytes of data, which we use to maintain navigational charts, publications and digital services to help mariners navigate safely at sea. Fundamentally, we are a data-driven organisation, and whether we are supporting the Royal Navy and our defence users, or 90% of large commercial ships trading internationally, our aim is to help them get from A to B in a safe, efficient and compliant manner. And we've seen firsthand the positive impact of combining digital technologies and rich data. We've been producing high-density electronic navigational charts, known as HD ENCs, based on high-resolution seabed mapping data. These HD ENCs are contoured at 1 metre intervals, enabling safer and more efficient navigation by opening up larger navigable areas for vessels and providing more precise data on the depth of water underneath the keel of ships. And we're already looking ahead to the next generation of navigational solutions, which will be underpinned by the International Hydrographic Organisation's new data standard, S100. These solutions will not only deliver richer data to the mariner for decision-making, but they will deliver it much more quickly than we've ever known before. We are only able to achieve all of this because of the valuable partnerships we hold with other organisations across the globe, including many of you watching online today, from other hydrographic officers to government partners, commercial partners, and a whole variety of other data suppliers. Because when dealing with data, we believe collaboration is key, particularly if we as an industry are looking to leverage this data to unlock efficiencies and reduce emissions. There is no doubt that we are stronger together. By pooling our expertise and insight, we will be able to move with the speed and agility necessary to support the evolving needs of the industry against the backdrop of challenges it faces. That was clear from our panel discussion, where we were fortunate to be able to be joined by a range of experts who offered their insights on how the technologies of today and tomorrow will help transform the way shipping operates. You will hear highlights from some of those conversations today, including discussions on how data is beamed from ship to shore, how it can enable improved decision-making and efficiencies, and even how it is helping pave the way for autonomous navigation. To help explore some of these topics today, I'm joined by Thomas Meller, Head of Technical Partnerships here at the UK Hydrographic Office, who is a member of our panel at London International Shipping Week. Tom.
Thanks, Peter. Good afternoon to everyone watching today. As you mentioned, I don't think we can underestimate the importance of accurate and timely data when it comes to effective decision-making. And during our panel, it was great to hear a range of those perspectives from those who are responsible for setting the regulations to those who rely on the data for their day-to-day operations. John Dillon Leach, hydrographer for the Port of London Authority, started the panel discussion with an interesting insight that really demonstrates the need for comprehensive data within the port environment.
Some of the things we've been doing that we do now that have an impact on the navigators is we produce fully compliant ENC data. We produce that in-house with the help and support of the UKHO, and then they distribute that. They give it a safety check, and we're generally compliant, pretty good. And that's really to help that sort of bridge-to-bridge comms and to get up-to-date data as soon as we can in one way to the bridge of the ship. So a bridge leaving Benzing or South American port has the data and those HDENCs that you see and the higher level data that we produce. And that sort of transitions and amalgamates really well to the Navigator. More recently, we've been looking at the S100 suite, and S102 is the bathymetric surface for that. So we've done some, the UKHO have the ability to generate that, and they're looking to generate it faster. Again, so we have timely data, and we've done some work in collaboration with one of our major port operators, CLDN, 3 of our pilots. We've over 100 pilots, and they've been looking at giving the mariners and the pilots' perspective to making sure that these new products fit the purpose, really. And then that feeds back into the work Tom does and others at the UKHO in driving the standards, really. So lots going on. And then this year we're looking at bringing that other important data in, such as S104, tides, tidal flows, etc. Because whether you're moving a passenger around, as we see below us here on the Shard, and we're up to 9 million passengers a year moving here, or you're bringing the largest container ship in the world into the port, it's amazing how dynamic and how important little bits of data are. So a flow difference of 0.1 of a knot can make a difference between a few minutes of when a tug latches on or not, and so it's really important.
John makes a great point about how even the smallest increments of data can have a real impact on maritime decision making. And the IHO's new data standard, S100, really is allowing for a greater depth of information to be produced than ever before. For those that don't know, perhaps, Tom, you can talk a bit about S100 and expand on some of the work that we've been doing with John and the PLA to trial some of these emerging product specifications.
Thanks, Peter. So maybe for some of you that don't know, S100 is the new geospatial information standard that's been developed by the IHO. And it's been developed to support a much greater variety of hydrographic information than ever before. Primarily, the old standard, S57, was developed to support the navigational chart, the electronic navigation chart, or ENCs. But with S100, it has a much greater depth and breadth of information than ever before. John talked about the tidal information that's included. He talked about the bathymetry information, which is also included in some of the product specifications that are being built out of S100. And I think the beauty of S100 is it's not just for navigational systems. It's been built so that it can be used by voyage optimization tools. It can be used by GIS. It can be used onshore by shipping companies who want to understand where all their vessels are going. So the breadth and use of S100-based product specifications is much, much wider than we had with S57. And to some of the trial projects that John was alluding to, obviously with a new standard, you need to test and make sure that everything that you're doing with the data will actually deliver the customer benefits that we're talking about. So we embarked on a trial with the PLA, where they went out and did some surveys to capture some high resolution data. We then processed that information at the UKHO to create that S102 bathymetric surface. And we worked with the PPU manufacturer, CIQ, to make sure that that data would display correctly in their system. And then with the pilots in the PLA, we worked to understand how using that data in their environment would ultimately open up sea channels for vessels to navigate safely through there. In the PLA, they have a lot of traffic, and so having the greatest area for navigation is obviously paramount, really. And using this data, we were able to actually see how the S102 data opened up the channel for the vessel going through, whereas previously on the old navigational information, some of those areas would have been closed off. So the pilot now has more navigable water to take that vessel into to avoid oncoming traffic. And it really was a good example of how this data will enhance the navigation for the shipping company, but also for the pilot. And an extension to that project that we're looking at conducting with PLA is to bring in the tidal information. So John talked about the S104 data sets and the surface currents information, S111. we want to understand, when you combine all of that data together in the PPU, how you can start to really leverage the power of the combination of all of that information.
Do you think, Tom, that we're making the case for S100 as clearly as we need to, the safety benefits, but also the operational efficiency benefits that mariners and operators and ports can derive from it?
Yeah, that's something that the UKHO really interested in doing, and helping to set that business case for transition from the current systems into S100. So we've been working with some of our OEM partners and the industry to start looking at how we can explain the benefits. And through these trial projects that we're conducting, we're gathering a body of evidence which will hopefully help to showcase all the advantages of moving to S100. So I think that's really how we can to support the industry as we move across into this new world. So as we can see, the S100 infrastructure that is being developed by the IHO really is one of the enablers for the things that we're doing with optimisation and fuel saving. And during the discussions, John also mentioned just-in-time arrivals, and specifically the importance of having standardised data and processes to help achieve that reduction in emissions.
The main driver for us is safety, but with safety comes efficiency. And Tom touched on, unless you consistently dredge a port, certainly a port like the Thames that's subject to change, it's not that sustainable, and it's highly expensive to do that. So what we do is we basically surf the vessels in on the tidal wave that we have here, maintaining an underkeel clearance of about 10%. But that just-in-time arrival is of huge importance, and it's that link between having a standard data set that allows the maximizing of cargo at the departure point and the arrival at a time that allows the vessel to get onto the berth. There will be congestion, there always is, but it's all the things that have to align, such as the tug has to be ordered, the pilot has to be available, has to be aboard, the data that the pilot needs to see for the passage plan they've prepared needs to be correct. If that pilot, he or she, gets aboard and they're expecting a draft of 13.3 and it's 13.5, that could make a 20-minute difference as to what they have to do, speed up, slow down, etc. So it's that data exchange and the formats that I think are critical.
It's clear that just-in-time arrivals have huge potential to support more efficient port operations and reduce the costs and emissions associated with the problem of sail fast, then wait. And at the UKHO, we are actively working with various partners and organisations to support voyage optimisation initiatives, such as the Blue Visby solution. Tom, you were there. What happened when Pekka spoke to us about Blue Visby and their proposals?
Thanks, Peter. So Pekka gave us an outline of how the Blue Visby concept could actually reduce emissions. As we've heard, sailing fast and then waiting is not good for the environment. We're having lots of vessels stacking up in anchorage areas, and this obviously is burning fuel, and fuel is very costly. And so the Blue Visby concept is looking to really optimise that whole voyage. So if you are sailing to a port and there isn't the availability of the berth or whatever, there's an ability for the shipping company to inform the master that they can sail slower until that availability becomes ready for the vessel to take, and the whole infrastructure is ready there to be able to be utilised in the most streamlined fashion. And this really is the concept of just-in-time arrivals as well. It's about making sure that the vessel has all the right information and everyone in that chain has the right information to optimise that voyage and reduce the emissions and therefore reduce the cost of the actual overall voyage.
I think what's interesting for me about the whole voyage optimization piece, and many of us have been guilty of the sail fast to wait in the past, is the really quite significant savings that we may be able to realise in hydrocarbon consumption and therefore carbon production. We're talking about figures of about 15% as opposed to new paint schemes and anti-fouling, which may only yield 2%. This is a really significant opportunity for shipping to make a major contribution to climate change reduction.
Yeah, and I think this is where our new S100 data can really play an influential part. With the surface current information and the tidal information, combine that with all of the weather that they've got available now, it really is a powerful time to be able to use all of that information and voyage optimization tools. And I think that we'll see in the future this becoming a really important aspect of the voyage planning process for shipping companies. But we can only begin to explore these potential voyage optimization and decarbonisation initiatives if we have the right data along with the right infrastructure to be able to share that data between ship and shore. And this is something that Carol Plessy from OneWeb discussed during the panel discussion, explaining the impressive ways in which low Earth orbit satellites are transforming communications at sea.
In the last 12 months, we've really seen a revolution in communication at sea. It's taken everyone by storm because the maritime industry is supposed to be one of those industries that are slow to adopt changes and transformation, something we talk about for the last 15 years. And in the last year, things have changed. And the maritime industry has been in the forefront of that change with the direct-to-home internet consumer. You see, the enterprise guys and the telco guys are slightly behind the curve, so well done. You've adopted high-speed, low-latency communication at sea. This is what low Earth orbit satellites provide. We've invested collectively as the industry, and we are investing around $50 billion putting infrastructure in space. And that huge infrastructure are thousands of satellites flying. OneWeb flies 634 satellites to provide global connectivity over the oceans. And we fly them at 1,200 kilometers from the Earth, meaning that we can offer you 20 times more bandwidth, 5 times lower latency, and 20 times more data volume that you've ever used. Just to put things in perspective, a vessel that adopts low Earth orbit constellation and effectively a LEO satellite connectivity will typically multiply their usage by 10. Most of it is by the crew. We're very aware of that. And typically, a vessel can go up to 1 terabyte a month of data. So 1 terabyte a month of data, what does that mean? That's 1,000 hours of Netflix. That's 100,000 high-resolution picture. That's a lot of video calling. So it's completely different from anything we've known before. But this is just to illustrate that we have really taken a turn as an industry to provide the infrastructure to allow the vessel to be connected ship to shore constantly. And this constantly and real-time data is very important. Because what you can do with real-time data is taking decision, processing the data real-time, and finally reaching that Goldilocks scenario, the just-in-time, just the right route, just the crewing, scheduling working, the right amount of port utilization, so we can deliver on this Goldilocks 20% reduction on carbon footprint. So I'm very happy to say that we have the tools at your disposal to make those changes in the industry.
That's really interesting to hear from Carol, and it paints a picture very different to my time on board various defence vessels as a navigator, communications officer and captain, where we certainly weren't able to watch Netflix over streaming. But I do believe it will be revolutionary for mariners to no longer be constrained by bandwidth, particularly when it comes to enabling near real-time insights to inform decision-making. Tom, how do you see this as an enabler for S100 and future navigation solutions?
Well, I think really the infrastructure that's being offered now by these low Earth orbit satellite communication systems is just revolutionary. It will allow us to start sending bigger data sets to vessels than we've ever been possible before with the older infrastructure. And it brings a different opportunity. We can start to look at sending data more regularly to vessels, which wasn't possible before. And UKHO have a project where we're decoupling our delivery of information, our E&C updates, from the weekly cycle, which has always been the traditional method of getting information out, to actually delivering it when we get it and when it's ready for dissemination, so that vessels can take the appropriate action necessary. It's no good us having information in a hydrographic office when the best place for that information is in the navigator's hands.
With the decision maker.
Of course. So the infrastructure that we're building will allow us to utilize all of these new technologies that are coming out now. And it really is, I think, a game changer with the ability for us to start thinking about tidal information, for example, which relies on possibly being delivered every 6 hours, maybe more frequently in different areas of the world. So we need an infrastructure that will allow us to transmit that information more regularly. And this is what it does, is it provides the core infrastructure really for us to be able to do things like that.
I think the other opportunity for the shipping industry as a whole is, we've had the Internet of Things ashore and in our daily life for many years now. We're starting to see that gradually emerge in the maritime environment as well. And therefore it's blurring that boundary between sea and shore for decision making and environmental monitoring and equipment performance as well. And this is the next logical step of that for me. We are going to be able to provide up to the minute safety information to mariners where they need it, when they need it.
Yeah, and I think that's really important, because obviously as we're talking about decarbonisation and things like that, we need to get information off of the vessels about where they are, about how fast they're going and things like that. And so you need that communication method to be able to do that, so that you can optimise those voyages. So all of this really is linked, and I see that the infrastructure really is the enabler. So closely linked to that topic of digital navigation, the audience were really keen to hear more about the requirements for autonomous navigation. And we had a couple of audience questions that related to maritime autonomous surface ships, or MAS, which steered the conversation towards the different levels of autonomy and supporting safe navigation for vessels without a crew on board. UKHO are very involved in the development of maritime autonomous surface ships. One of my colleagues at the UKHO actually leads the IHO working group responsible for looking at this sector and seeing how the S100 suite of products will need to adapt and change to meet the requirements of that new sector. So, as I said earlier, one of the things that we expect in that area is that if you go to degree 4, where there's not expected to be any personnel on board, the type of data that vessel would require could be very different from an autonomous vehicle that has someone on board who may want to view the information as well. And so that's what this group at the IHO is seeking to establish, is what data formats would be necessary for each level of type of autonomy. And these test beds that we're talking about will be a brilliant place to gather that information and see what we can provide today and what we need to be providing in the future.
The question around autonomy is that it's the data connectivity that allows us to get data both ways. I think it's a game changer from the point of view of sustainability and efficiency. And I think there's a lot going on in the space at the moment. I think in a port environment, autonomy is a long way off, but remote, the possibilities of remote is allowing to either control. You could have remote pilotage to a certain level, or you can have that ability that you have a fully remote, uncrewed vessel working in certain areas. So I think there's a lot of work to go on. The port environment's a good place to get those stakeholders together to look at the safety case of those.
Well, the concept of truly autonomous vessels may feel futuristic. We're still seeing more and more tangible steps towards semi-autonomous technologies and shore-based automation. I think in the development of S100, as we have discussed today, it will be hugely important to consider the data requirements for both crewed and uncrewed vessels alike. And so, as we look at this, Tom, how do you see that shift from information that has been developed for people to interpret to machine-readable information for autonomous vessels?
So I think the data requirements could be very different. A machine that doesn't require any interaction or any human viewing that potentially can take a lot larger volume of information and a greater depth of information than we've ever been able to produce previously, where humans had to interact with the system. And therefore, the requirements of those autonomous systems are likely to change the way in which we produce our products. And this is why the UKHO are so keen to be involved in the development of this, so that we can start to understand those user requirements for all of those systems. We have a number of test beds that we're working on with maritime autonomous ship designers of these systems, and we're looking at how we can really understand their user needs in much more detail, so that we can go back and look to refine the standards over time at the IHO, because the S100 infrastructure is extensible. So at any point we can look to include new requirements from the industry that mean that we can extend the standard to support these emerging things. So it's not static, and it is able to adapt and change over time, which is good, because obviously that means that these future requirements can be built in at a later stage. And I think what we will see is, as we get more familiar with these autonomous systems and their data requirements, that the S100 standard will ultimately be changing over time to reflect those.
And do you think the world of regulation is moving at the speed of relevance at the moment? Do you feel that we're going to be ready to embrace autonomy when it is truly available?
I actually think that there's a lot of work that's being done in the autonomy space ahead of the regulation. As you know, there's a lot of survey vehicles now out there collecting masses of information for us to be able to map the seabed. And these vehicles are doing it sort of inside, outside the bounds of the regulations at the moment, because it's just not moving at the pace necessary. I think the technology's here and is maturing quicker than our ability to set the standards really for that.
And we've been working with autonomous and semi-autonomous survey craft for some time. In fact, as we speak, we have 4 autonomous vessels currently surveying in a pack in the southwest approaches of the UK economic exclusion zone. And it shows real benefits and economies of scale in having those autonomous vessels, and lower carbon as well, crucially, which I think we have got to try and explore and perhaps understand better going forward. But it is a gain loss, I sense. So it's been really interesting to hear about these conversations during the panel discussion, and how advances in connectivity and digitalisation are helping to lay the foundations for a safer, more efficient and greener shipping industry. I'd now like to open up the conversation to some of our audience watching online. And so if you'd like to use Slido, please do pose your questions now. I think we've got some already, so I'll have a look on the tablet to see what we've got. And I think I'll read the questions and I'll give you the difficult ones, Tom. So
Peter.
Could you share a list of S100 benefits and contributing and seeing the contributions it makes to navigational safety? I think we probably could.
Yeah. I think, as we've already talked about, it's not just the S101 data set, which is your traditional navigational chart, that will be the biggest benefit to users, although there are significant changes in that product specification, like the placement of text and the fact that we now have machine-readable catalogues, which will allow us to update products at sea without the need for costly maintenance and things with people coming on board to maintain the equipment. But it's the combination of when you use that information, like the S102, which is your bathymetric surface, and your S104, your water levels, then you really start to build in this dynamic picture of the natural environment, which can improve navigational safety, but it can also improve operational efficiencies for ports. It supports that just-in-time arrivals that we've talked about. So all of these are the contributing factors which really make moving to S100 such a compelling reason and a powerful argument for adopting the standards as soon as possible.
The next question is another really good one. How can tidal information be used to support voyage optimization? And I think, I reflect on my time at sea, and I think of the benefits that ships I've been in have had from going with the ocean current up to a knot and a half in places, thereby helping to reduce the speed consumption that you have to ring on, and thereby the fuel consumption. I think the other great insight that I had was from a port operator that remarked that every metre under the keel that you can open up for a ship going into a tidally constrained port can effectively amount to 1,000 extra containers on that ship. That's a really compelling business case, both in operational efficiency for the ship, but also the port operator, increasing the length of its tidal window, which can only help the profitability of the port and the effectiveness of its port operation. So that's another one. The next one is definitely for you. So this is, how do you think we can build resilience in an uncertain world to meet shipping's challenges? It's a great question.
Yeah, I think some of what we talked about already with the S100 standard being extensible. So as new requirements come on board, there's a way to extend the standard to support those new requirements. But also, I think within this whole discussion, what we haven't talked about yet is the cybersecurity of the information. And with digitalisation comes the increased threat of cybersecurity issues. And that was something that came out through the discussions at International Shipping Week, London International Shipping Week, which really it seeks to show the concern that people have about moving to connected ECDIS. And we do need to take those concerns really seriously. And obviously with the increased threat of cyber terrorists and risks posed by foreign actors, it just is a thing that we really need to take into account. And so with S100, what we're doing is we're improving the security scheme and the way in which all of that data is disseminated. And this hopefully will be one of the benefits of moving to S100.
I think that encryption is key. The S57 standard has been around for so long, it is now so vulnerable really to compromise. But I think one of the other benefits that we in UKHO have is the backing that we have from our own government in terms of that cybersecurity and resilience. A reflection would be that for most organisations, it's not a case of if, it's a case of when, but it's the manner in which you recover from that event that is most important. There was a really good question about tidal information. It said, how can you improve the quality of tidal information at UKHO? And the observation was particularly around US ports.
Okay. Obviously, a lot of the work we do is working with our international partners, and gathering that information is obviously key. And one of the things that obviously with our astronomical tides and things like that is that we have to take the tidal readings from the stations, making sure we're getting accurate readings from all of those tidal stations is going to be really important, because that's what feeds the machine, if you like. That's where we then use that information to do all the tidal predictions. So if there's any spurious information in that, then the filtering needs to be, and the validation of that information feed needs to be done in a way which assures us that the information we're putting in will be correct.
And with the digitalisation of tidal gauges, and that ability, that communication capacity that Carol talked to, we're going to be in the business of giving real-time tidal information at the port, at the lock gates, rather than based on the harmonics that we've been forecasting previously. We're looking at true forecast rather than harmonic prediction.
That's a really interesting point, because we go from the astronomical predictions into forecasts, where you're bringing the weather and tide information together, and then you've got that true real-time information which could be broadcast. What does pose a question there is, though, how do we validate the information that's going into the system to adjust maybe our depth information for that real-time information is correct and isn't spurious, and that there's one gauge maybe that's out slightly and is not reporting the correct information. So working through that is still something which is being done at the UKHO to understand how we can accept real-time feeds in without jeopardizing the safety of the vessel because of some spurious reading. So those are things that we really have to work on.
And it is a major interest for us at UKHO as we look to S104, S111, and eventually the S129 standard. So I'll move on to the next question, which is also definitely for you as well. From Andrei Sebedash, how do you see the transition period for simultaneous usage of S57 and S100?
Okay, so some of you may know that the performance standard for S100 was approved by the IMO in November 22 last year. And what this did is it set out an introductory timetable. So we're expecting that from the 1st of January 2026, that there is a standard then, a performance standard that ECDIS systems can be type approved against, that means that they can be used for navigation. Now, the first generation of S100 ECDIS will support not only the S101 standard, but also your S57 ENCs. So it means that there'll be dual fuel in all aspects. As we move forward into the next few years, when we get to the 1st of January 2029, the IMO will retire the old performance standard. So you will only ever be able to install a new ECDIS system that complies with S100. So it will be possible to also display your S57 ENC still, but it will be able to display and use and utilize all of the S100 family of standards as well. So that's the timetable for introduction. What it means is if you're still using your old S57 ECDIS today, it will still be compliant, but obviously, hopefully over time, people will start realizing all the benefits that can be achieved with S100 and will want to move to the new standards and the new systems that support that.
And the next question is related, when are we likely to see the first S100 data actually used in ECDIS? And I think you've said about that. It might be helpful to talk about some of the trials that we're currently doing on S100, trying to understand the dual displays and so on. Can you tell us a bit about that?
Yeah, sure. So we have a project with the CHOM, which is the French Hydrographic Office, where we are working with a number of ECDIS manufacturers who are very active in the IHO and very forward-facing, really, looking at all the standards and influencing those standards and developing them and putting them into practice in their systems. So we're working with Navtor and Furuno and OSI, who building the WECDIS, to build a number of S100 systems where we can trial data from Southampton going across into St. Malo. So we'll be looking at S101, the navigational chart, but also combining that with our S102, S104 and S111, so that we can really start to understand all the benefits of using that information. And the idea being that the trial area that we've chosen crosses a national boundary a number of times, because we're navigating down through the Channel Islands, which are owned by the UK, and so we have to cross those boundaries of international charting a number of times, which really throws up a number of challenges for hydrographic offices on how we share those boundaries across with multiple data products, which we've not had to do before. We've only ever had the navigational chart, whereas now we have a number of other navigational products which we need to harmonise and make sure that it all works as we would expect. So those trial projects will really help us to understand what some of those challenges are.
And there's nowhere more dynamic to test the tidal properties of S100 than the Channel Islands. The next question is one I'll answer. So it's how are benefits of HD ENC going to be balanced against security requirements in terms of publishing such information for strategic ports? And I think clearly we are the provider of global hydrographic and navigational situational awareness. We work with international partners, over 140 countries, but we also work with in excess of 1,000 ports. We would take the information that we're provided. And so if a government were to deem it to be of strategic interest not to disclose some of that information, we would clearly respect that. I think, though, many governments recognise the benefits of unlocking some of that understanding so that they can improve the operational safety of ports. Few ports can cope with the business continuity issues associated with a grounding or a vessel foundering in its port, that is a bigger risk to most people than malign actors. But we work with our data suppliers to ensure that we protect their information and safeguard appropriately. The next one is a good one, one that's very much a recurrent theme about paper and digital. So do you have a contingency plan if the big data fails to be properly received on board, where it can cause errors in ECDIS due to slow internet connection?
So I think the thing to say really here is that we have a number of solutions that people are working with at the moment, where we have iPads like this, which have Get Your Home folios, which are all digital, which are separate from the connected ECDIS. And again, at the moment, there are vessels that are navigating that haven't updated for a number of weeks. The same thing would happen there. You would have to just assume that the data that you had on board was good, that you had updated as frequently as you could up until that point, and then you would have to just trust that the information that you had was sufficient. But obviously, when you come back online and you are able to get that internet connection back up, you can start installing all the updates from the point at which it went down. So there is no problem with getting yourself back up to date, I think, and that's the thing really, is that it's better to have all of the information all the time than be without that information. And I think we've been doing some testing with Chartworld, one of our distributors, who at World ECDIS Day had done a study into how frequently the updates and things were being distributed to their vessels. And actually, it's not really that frequent. I think we need to remember that over the global series of navigational charts that we have in AVCS, there are just under 20,000 at the moment. And on average, there's probably around 200 updates per day. So we're not talking about masses and masses of information that are going to mean that you'll have to change your passage plans and things like that. It's information that's drip fed down. And if it is navigationally significant, just like your navigational warning that you would have had on board, you'll have to take avoiding action. But unlike the navigational warning, which you'll have to have plotted manually, this will automatically have come down and be applied to the chart if that's what the mariner wants. So I think that's the difference, is it's actually just going to save time, really, ultimately.
And I think, relatedly, there's a question here, as the reliance on large data sets inevitably increases, how will key S100 data be supplied to ships if LEO or other subscription services are unavailable? And I think, lest we forget that our current and, our partners' weekly notices to mariners was the product of a system developed over 100 years ago so that notices to mariners could be distributed by the steam packet service as it sailed. I think services will still be operable in the S100 era, and they will be updated when that connectivity is remade either at sea or alongside in port. And I think that's a key thing for all these services. The next one is, I think I've said about simultaneous usage of S57 and S100. Tidal currents, I think this is more of a statement. Tidal currents are not in hydrographic officers' hands. How do you see practical S100 implementation in meteorology and oceanography? I think my sense is that whilst we have relationships with hydrographic officers, we also have relationships with all the ports. And many of the environmental agencies, such as NOAA, that provide that data as well. So we will be working with a wider variety of data partners in the future. So the next one is definitely for you. What would you say is the lowest hanging fruit, easiest implementations that will have the quickest and first and significant impact on navigational safety?
So I think really for me, it's the combination of the S102 and S104 data with the S101 information. As we've talked about, with the HDNCs, the information that we created first with our electronic charts didn't really have enough contours in them for mariners to set an accurate safety contour. So it was always defaulting to the next deepest contour. However, with our S102 data and the tidal information, you can set a very, very highly accurate safety contour, which will denote your safe and unsafe areas, allow you to load more cargo, allow you to plan more effectively berth-to-berth passages, and really give you the areas that you can and can't go. Whereas previously, it was always, you know, the navigator having to interpret the information that we had provided in our ENCs, whereas there will be no interpretation now. If you sail across that safety contour, then
you sailed across the safety contour.
You now have a vessel that's gone aground. So it is a step change, but it obviously will give you the maximum navigable water, and obviously should help with, you know, opening up passages which previously were very constrained.
And I think that's been a key factor in our prioritization of the products that UKHO develops.
Yes.
It's those that offer the key operational and environmental benefits first, and that's S101, S102, S104, S111, and I can't think of the other one, 124, I think.
Yeah, but navigation warnings.
So these are the services that we are seeking to prioritize in the S100 development. So that was from Petter. Thank you, Petter. How do you assure data validity in case of real-time data sent to be integrated into S100 and ECDIS? Who can send data? Any visibility of the data sources?
Yeah, I think this is the point that we were trying to make earlier, really, is that when you do have real-time feeds, how do you validate that information isn't spurious and doesn't have any problems? And I think, you know, whilst this is still to be worked out in detail at the IHO, at least you can see that actually having predictions and models that you can compare that against to make sure that it isn't wildly out would be the first step. And so those are some of the things I think that will be used to weed out any of those real spurious readings that would throw everything out. And then we'll just have to look in more detail about how that would work.
But that assurance process, that validation, has always been a key part of the way in which we work.
Yes, yeah.
The next question, again from Petter on tidal. Are all technology developments really worthwhile and viable? E.g. lots of money invested in improving tidal accuracy within a minute or two? I think that's a really good question, Petter. You know, there are some things which will offer marginal benefits and others which will offer significant benefits. I think it's important to look at what the aggregate is. You know, those benefits may unlock centimetric accuracy or minutes by minute accuracy on tidal, but the aggregate may be a better product. But I think you're quite right. We'll have to understand what the business case is for some of those products and services, and what do navigators and masters really need, together with port operators and pilots. Do you see a possibility of using S57 together with S102 and other data in S100?
That really I don't think is possible when we're looking at the S100 suite of standards. It's been made, the IHO have made the statement that that wouldn't be something that would be supported, primarily I think because of the intricacies of trying to map all of the interoperability across from each of the different products. The focus is solely on S100 and all of those standards that have been built using ISO 19 family of geographic information standards, rather than looking back at S57. So no is really the answer for that one. It simply is your S57 ENC, and then you'll have all the integration will be done on the S100 stack of information.
Yeah. The next one's a great question. What technology or trend are you most excited to see within the shipping industry?
Oh, blimey. I think really for me, the low Earth orbit satellites are the thing that excite me the most. As you know, Peter, I made the trip down to Newquay this year, or was it last year, to go and see the first launch of the satellites on UK soil that never happened. So I'm really enthused about the fact that the communication now means that we can sort of think about doing things differently.
Yeah.
Our data volumes in charting that we're talking about are so small and almost insignificant on on a scale that Carol was talking about in terms of streaming Netflix and things like that. So we don't have to be constrained so much anymore about the data volumes and things. And the pricing and things that she talked about actually is going to be very, very comparable to the price that's being paid today for internet connectivity, which isn't, is 10 times slower than the type of speeds she's been talking about. So I think that's the thing for me, is that the cost for the operator is going to be very similar for 10 times greater speeds out at sea, and that's the game changer, because it underpins so much of what we want to do.
I think the same is true for me. That connectivity is going to underpin autonomy. It's going to underpin rapid data collection and dissemination. It's going to enhance that safety awareness that mariners can be provided. And I reflect back to times when I've not had satellite connectivity at sea before, and how utterly alone you feel when you don't have it, and that connectivity which you then get back, which can be a blessing and a curse sometimes. But I think it really will change the way in which we operate at sea, and those updates will be fundamentally far better. Which brings on to the next question. How will autonomous data collection impact how the UK's current ways of working?
I mean, for us, it's going to mean greater volumes of information. Only next week, I have a call with a company called Mythos, who are doing work in building autonomous vessels to do survey work in ports and things. So we're going to be getting a greater volume of information, and obviously with that, we have to look at the validation of that information, making sure that actually everything coming through is correct. But it's something that we're used to now. We've been working with multi-beam information for many, many years, and we're able to process that information in-house. I think that we are going to have to look at new ways of working, possibly, to be able to process the volumes of information that we need to. And obviously on the back of that, we're going to have possibly two different products, one for autonomous vehicles that may be different from the one that the traditional navigator is going to be using. So there are some challenges for us, definitely, but I think it's nothing that we couldn't handle.
I think the interesting, exciting thing for me is that initiative that we have running called Ping to Actis, which I've shared with colleagues previously, where we're looking to ingest data straight from the survey collection, potentially straight from the sensor, with edge processing into the organisation as soon as the survey is complete, to turn it round within a matter of hours and then have it back out. When you look particularly at some of the riverine areas that mariners operate in, the Schelde for Antwerp, which is surveyed 3 times a week, London. These very dynamic ports need that frequency of update. So will S102 HDNC increase contouring over drying heights? This is an area lacking in S57 chart, noting the shoaless contour for safety contour is 0 meters. It's a really good question.
Yeah.
Should do, theoretically.
Yeah, theoretically, I think it should do. In all honesty, I'm not entirely sure on that one, so that is one that has stumped me. I'll have to go back.
I think we might have to take that away and have a look. But It's a great question. I'm sorry you didn't put your name on that. We'd like to come back to you on that. That's a really good question. The next one is, how do you make sure information is reliable? Tidal information is almost never exactly the same as predicted, but as captain, I need info on departure. I think that is a key role that we have to ensure the integrity and veracity of information before we push it out. And that's been the hallmark of Admiralty for many years. And I think looking at tidal information in the future, looking to see how we work with ports and other partners to ensure we have that accurate information, making sure they're properly calibrated, making sure there is a vertical frame of reference that everyone's operating to. That's a key part of how we operate. But it's I share your pain about never being exactly as predicted. And I think that's where we're looking to move to, which is going to be more of a forecast rather than a prediction, taking into account atmospheric pressure, taking into account freshwater runoff, taking into account all manner of things such as surges.
I mean, on that point, Peter, the trial that we're running with PLA, we're putting some buoyage out into the river, hopefully, that will enable us to understand if the model that we've created, the forecast model, is actually accurately, is reliably giving us those predictions. So we will be validating the model that we're using, and if there are any differences, we can obviously get the information off of that buoyage to put it back into the modelling process to improve that prediction ultimately. So we obviously really want to understand that the models that we're using to do our forecast are correct, and obviously validating those with measuring buoys out at sea is something that we're going to do.
I have just noticed that Andre's picked us up because I think you mentioned the Channel Islands were owned by the UK. They're Crown dependencies.
Sorry.
And British Protectorate. So the next question is there anything built into the new standard to highlight recent changes to chart data?
So we have a way in which you can review automatic updates within the ECDIS system. That's already there. However, what we're looking to do is to improve that, the way in which they're presented back to the user. At the moment, I think there are a number of different ways that ECDIS manufacturers show where changes in the E&C chart have occurred. And what we're looking to do is to make sure that everyone is doing it in a standardized way, which only shows you the actual change that's occurred, rather than if you have a very long contour or something like that has maybe just changed slightly. Sometimes in some ECDIS systems, the whole contour would appear orange as if there's some change, whereas actually the only change was in that very small part, and so what we're looking to do is to standardize all of that.
Well, Tom, I think that brings us to the end of our questions. So I think it just falls to me to say thank you to everyone for your questions. Please do keep an eye on the Admiralty website, our website, where we will be producing follow-up content on the various topics discussed today, including any questions that you might subsequently ask, and we'd be delighted to take them. What is clear from the panel discussion and these conversations is that we face an exciting new chapter for shipping. While we may still be seeking solutions to some of the challenges associated with digitalisation and decarbonisation, the data at our fingertips has been never greater. And by working together as an industry, I truly believe we can leverage that information to reach our shared decarbonisation goals and realise the benefits of digitalisation as we become increasingly connected from ship to shore. Before we bring this webinar to a close, I wanted to thank you all for joining us today, all 574 of you. It's thanks to your participation and feedback that we are able to hold events like these. So we would be really grateful if you could fill in our short survey on Slido to get your views on our webinar and Tom, and understand which topics you would like to hear about next. I do hope you found these conversations insightful as we move towards the future of navigation together. Thank you all again for watching.